This video is going to cover Section 1.1 regarding graphs, and it's going to cover targets 1.1 and 1.2. Target 1.1 is that you can graph a function both by hand and with a graphing calculator, and target 1.2 is that you can determine the x and y intercepts of a function both algebraically and graphically. To begin the review, our coordinate system is called the rectangular coordinate system. This is where we graph our x and our y coordinates. It's also known as the Cartesian coordinate system. It's broken up with two axes. We first have the x-axis, that's along the horizontal, and then we have the y-axis, that's along the vertical. The point in the middle where the two axes meet is called the origin. This is the point 0, 0. If you want to plot a coordinate, going to the right is the positive x values, and going up is the positive y values. So in quadrant 1, we have both positive x's and positive y's. If we start at the origin and we go to the left, our x values are negative, but if we go up, our y values are positive still, and this is quadrant 2. If you're starting in the origin and you go left and down, our x values are negative and our y values are negative. This is quadrant 3. And finally, quadrant 4 is going to have positive x values but negative y values. So just for a little practice, go ahead and plot these 4 points. First plot -3, 2, that's point A, then plot 2, -4, then plot -1, -2, and then plot point D, 3, 1. Pause the video and come back and check your work. Point A is at -3, +2. So -3 is to the left, +2 is up. So this point A is in quadrant 2. Point B has a positive x value, so I'm going to go to the right, and then a negative y value, so I'm going to go down. This is in quadrant 4. Point C has a negative x and a negative y, so I'm going to go left -1 and then down 2, and that's going to bring me to point C in quadrant 3. And then point D has a positive x and a positive y at 3, 1. If you were asked to graph an equation, so for example, I've already made the table for you on your note sheet with the x values from -3 to 3, we are going to plot the equation y equals 4 minus x squared. First thing you want to do is plug -3 into where you see x in the equation, get the y value, and then you'll write it out as an ordered pair. So for example, if I plug in -3, I'm going to square -3, then I'm going to subtract it from 4. So then I get 4 minus 9, so I get a y value of -5. Repeat these steps and get the y values for the other x values, write out your ordered pairs, and then come back and check your work. So pause the video right now and fill in your table. Here is what your here is what your table should look like after you've shown your work. Now you don't always have to show your work. I just might ask for the ordered pair or ask for the x and y values. But I'm showing you that in the equation we're subtracting x squared, so we're going to square it first and then subtract it. So you'll notice when I plug in a positive x value, I square it and then I subtract it from 4. So here are the ordered pairs. On the graph below, I want you to go ahead and plot your points. And so here they are already plotted for you on my screen. Go ahead and put that on your note sheet. And then you're going to connect the dots and it's going to make a parabola. And it looks like this. So graphing equations, plug in the x value into the equation to get the y value, plot the points using the coordinate system, and then connect the dots. You should be able to do this by hand. This is target 1.1. I'm also going to have you guys do this with a calculator as well for more difficult equations. So here's a little recap, or maybe you are not as familiar with a graphing calculator as other people are. So I just have some arrows pointing to some different screens. These are probably the most important buttons you will need for this course. So to begin, your mode. This is the most important thing right now, your mode. If you click on the mode button, it's already defaulted to all these. You can just leave it like that. We won't need to change any mode until we get to our second trimester. Then these buttons along the top, right underneath your screen, are going to be very important for graphing. The first button is your y equals. This is where you plug your equations. The second button is called the window button, and your standard screen is always going to go from -10 to 10 in both the x and the y values with a scale of 1, so it's going to go 1 through 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can also scale it to go by 2, so then it only goes 2, 4, 6, 8, etc. The third button is the zoom. The zoom button, we'll probably leave it as a zoom 6, that's your standard screen. You might use zoom in and zoom out. We won't use this as much until we get to second trimester. The third button is trace. That's kind of self-explanatory. If you ever want to trace a point or trace a graph, you can just click that and your cursor moves along the graph. And then the last button is the graph button. If you were to have something in the y equals window, it would go here. So right now I just have 4 points that are graphed. And then you'll notice I have blue arrows as well to these same buttons, but it's kind of like a shift key on a keyboard. You have to hit the second button first. So if you were to hit second and then y equals, that's going to take you to your stat plot screen. You might have used this in statistics. We will be using it, but probably not until our second trimester. If you were to hit second and then window, that'll be your table settings. This is going to be really an important feature when you get later on when you're trying to fill out tables and you have to fill out a value of -5 or you have to fill it to a value of 100. You can just ask the calculator what the y value is without having to scroll up and down your table. So that's a pretty cool feature. If you were to hit second zoom, that's a format feature. We won't ever use that in here. Second calculate will take you to a screen that I don't have listed on here. You might be asked to calculate the minimum, the maximum, or an x-intercept. That's another good feature. And then if you hit second graph, this will be your table feature, and this will be where you can see all your x and y values of a particular equation that you've put in your calculator. So this is just a recap of the graphing calculator. I'll be doing explaining more of these in class. One more thing regarding windows. In your textbook, you might see a window displayed from a calculator like this, -5, 3, 1. This means that the x-axis is going from -5 to 3 by an increment of 1. And so I have an example here of what you'd see your x-axis as. And then if it says -5, 3, 1 by -4, 10, 2, this right part means that the y-axis is going from -4 to 10 by values of 2, so 2, 4, 6, 8, etc. The second target that this video is covering is regarding x and y intercepts. An x-intercept is the x-coordinate of a point when the graph hits the x-axis. Also, when it's just what x is when your y value is 0. The y-intercept is the y-coordinate of a point when the graph hits the y-axis, or it's just what your y is when your x value is 0. So a couple examples that I have on your note sheet are graphs that, this is an upside down parabola where it doesn't have any x-intercepts, it has one y-intercept. Here is a sleeping parabola where it has one x-intercept and no y-intercepts. So there's lots of different ways that a graph can hit an x or a y-axis. So finding intercepts graphically is pretty self-explanatory. You want to go along the x-axis when you're trying to find your x-intercept. So we have an x-intercept here at 2, 0. This was the graph that you had earlier. And then we have another x-intercept at -2, 0. So we have 2 in this case. And then we only have one y-intercept. A y-intercept is when the graph hits the y-axis. It's up here at 0, 4. You also will need to be able to calculate intercepts algebraically. So calculating an x-intercept, all you have to do is plug 0 in for y and then solve for x. If you're calculating a y-intercept, you plug in 0 for x and solve for y. So I have a couple of examples, and then that will wrap up the video. So example 1, calculate the x and y intercepts of 4x minus 3y equals 12. So let's do x-intercepts first. That means that my y value is 0, so if I plug in 0 for y, I'm going to get 4x equals 12, which means x equals 3, and I can write it as a coordinate 3, 0. So this is a line, this is a linear function with an x-intercept at 3, 0. The next part, I want to find the y-intercept, so that means I'm going to plug in 0 for x. I'm going to get negative 3y equals 12, so that means y equals negative 4, or I have a coordinate of 0, negative 4. And my final example is a quadratic, or a parabola. First thing I want to do is calculate the x-intercepts. If I have an x-intercept, it means my y value is 0. So I'm going to plug 0 in for y. Okay, this is one where we're going to need to factor. So if you like to use the diamond method, you can, or box method. I'm going to find that negative 5 and 2 multiply to a negative 10 and add to a negative 3. So these are my factors. So then zero product property tells me that x would be a positive 5 and a negative 2. So then I have two x-intercepts at 5, 0 and at negative 2, 0. And then lastly, the y-intercept for this parabola is pretty simple. Plug in 0 for x. You'll notice that it's just going to be the constant at the end of the equation. So when I plug in 0 for x, I get that negative 10 at the far right. So then my coordinate is 0, negative 10. This is for the y-intercept. So this video covered targets 1.1 and 1.2. Hopefully you remember these from Algebra and Algebra 2. This is just a good recap video. Tomorrow in class we will be doing some group work based off this and also an assignment. Have a good afternoon.